In this video, we're going to look at finding the equation of a line, and I'm just going to use two examples to demonstrate the principle. So let's have a look at the first one. So we need to find the equation of this line, and it passes through an x-intercept of -2 and a y-intercept of -3. So the first thing maybe we could look at is let's find the gradient. We have a y-intercept already, so this lends itself well to using the gradient intercept formula of the line, y equals mx plus c. Now we have the plus c already, which is -3. So y is equal to mx minus 3. So we just need to find the m. So we could either use the 2-point formula, or we could recognize by inspection that it's going to be a negative gradient. It's going to have a run of 2 and a rise or a fall of -3. And so it's fairly easy to just note down, in fact. So run of 2, fall of -3. Okay, so therefore the equation is y equals -3 on 2, x minus 3. And if you want to write that in general form, we could just multiply everything by 2 so that we eliminate the fraction. So we could write it as 2y is equal to -3x minus 6, and we can move everything over to the left hand side. So this will be 3x plus 2y plus 6 is equal to 0 if you want the equation in general form. Okay, let's have a look at the next example. And it's not drawn to scale, but we can see that it's going to be a positive gradient as well. This time around, the y-intercept's not given. Okay, so we're only given an x-intercept, and we're given a point A that the line passes through. So we clearly have 2 points. Okay, and I think it's good to notice this, that the x-intercept has, in fact, a coordinate. In fact, I'll write this in a different color. So the x-intercept, in fact, has the coordinate 2, 0. Okay, just because it's written as a single number or a single figure, it doesn't mean that it doesn't have a proper coordinate in terms of 2 values, okay, separated by a comma. So we could either use the 2-point formula for gradient again, the m equals y2 minus y1 over x2 minus x1, or we could in fact recognize, okay, you don't have to do this, but it's just doing this for the purpose of the video. We can see our right angle triangle there, and we can in fact calculate the gradient immediately. So m is equal to rise over run. Okay, so we have a rise of 3 over a run of 2. So from 2 to 4. Okay, so this is the next coordinate of 4. Okay, on the x-axis. So from 2 to 4, we have a run of 2. Okay, so this is, if you're going to use the gradient intercept formula, this is 3 on 2x plus c, but we don't know what the c is. Now, we have two options. We could either use the point gradient formula, that's in fact probably easy enough to use, and substitute in one of these 2 points, or we could in fact use the gradient intercept formula and substitute in an x value of 2, y value of 0, and then we can solve for c. In fact, let's do that. So when x equals 2, so because the line passes through the x-intercept, when x equals 2, y equals 0. And it satisfies this equation. So 0 is equal to 3 over 2 times 2, so we're substituting in this coordinate into the equation, plus c. 0 is equal to 3 on 2 times 2, so that's just 3 plus c. Therefore, c is equal to -3. Happens to equal the same y-intercept as the first example. So that's just purely coincidence. So therefore, the equation is y is equal to 3 over 2 x minus 3. And that's how we find the equation of a line.